The title of this talk is C++ should be C++, and just a little bit about myself. My name is David Sankel. I am a principal scientist on the software technology lab at Adobe. This is a team which is charged with training and tools and research, but in general our goal is to be looking ahead, like the next 10 years, what's going to be happening in the software development industry, and in particular as it relates to programming and programming languages and things along these lines. I also participate in the C++ standardization, and a lot of it is in the library evolution working group, and I'll talk a little bit more about that later on. But anyway, we have this talk and the title is C++ should be C++, and hopefully you have a sense of what that means by the time we get to the end. So let's talk about C++. So C++ is a language that does a lot of different... Go away, Rust. All right. No, C++ is a language that solves a lot of different kinds of problems, and we have to look at how it... God damn it. Okay, look. If we're going to talk about C++ today, we have to talk about Rust. We cannot talk about C++ in isolation without talking about Rust. So let's go ahead and get this over with. Let's talk a little bit about Rust. In particular, some of the things that happened recently, there was a White House thing that came out, press release, future software should be memory safe, and in it it said C and C++ are not memory safe languages, unlike Rust. Okay. And then there was another document that came out called the Case for Memory Safe Roadmaps. You probably can't read that. I can barely read it, but it says executive level leadership should drive the transition to memory safe programming languages because memory unsafety is fundamentally a business strategy problem. As such, the CEO or other business executives should sign the roadmap. Okay, so they're encouraging that businesses come up with roadmaps to move away from unsafe languages, which is code word for C or C++, to a safe language, which is like a bunch of other things, but probably Rust. So there's that. Also, there was this document that came out a while back. This is a thing that came from Consumer Reports, surprisingly enough. And it said a lot of things, but one of the things it says is some resistance to moving off C/C++ is due to the sunk cost fallacy. Using Rust for new projects will ultimately result in higher productivity. And then we had this. It says a bill, and it's literally a bill that came before, I believe, the House of Representatives. And this bill said to establish a new Department of Defense policy, which has conditions and associated approval process for buying software using memory unsafe languages. In other words, if you're going to buy software that's written in a memory unsafe language, then there are going to be additional hurdles you need to go through, and generally government is going to be trying to discourage people from buying software written in unsafe languages. Okay. Now this bill went through the House, and it ultimately got removed because I think the Senate version of this bill didn't have this in it. Maybe some like fancy lobbying happened or something along these lines, and it got removed. But this whole thing here is not going away, okay? This is the state of the universe, is this major push towards Rust. Okay. So Bjarne had this to say. He said, if I considered any of these quote unquote safe languages superior to C++ for the range of uses I care about, I wouldn't consider the fading out of C/C++ as a bad thing, but that's not the case. And then we have Herb in a more recent blog post who said, in C++, a 98% improvement in the four most common problem areas is achievable in the medium term. Raise your hand if you believe that. Wow.
We got one just.
Wow. Okay. There was one, maybe two. Whew. All right.
You know what I think of medium.
What do you think of medium?
There are some, long term is a very long time.
Long term is a very long time. Yes. This says medium.
Yeah, how long is medium?
Less.
Almost
as long as you think.
20 years?
I don't know. I would say maybe it could happen, but it seems unlikely to be doing so in where it's actually relevant, given the immediacy of the need for this other stuff. That's my take. And by the way, this is very much an interactive talk. Feel free to raise your hand, talk, whatever. It's meant to be a discussion.
I have a question then.
Yeah.
What do you think is immediate about the rest of the stuff?
What do I think is immediate about the rest of this stuff?
I mean, has anything actually changed, or is it just a meme going around at the moment?
Is this just like a meme going on? Well, I mean, the stuff that I showed was all like US centric, but it's also happening in Europe through parallel things. How long it's going to take for legislation to ultimately happen, and then for a company or like a government to go to a company like Adobe and say, hey, we want you to tell us what your memory safety plan is. I think that's probably a few years away.
So the immediacy is taking action. I mean, I don't think the facts have changed in any significant way, right? It's just a matter of attention. Attention from the wrong places, maybe?
The facts haven't changed. Correct. I think that C and C++ have not gotten more memory unsafe.
Exactly.
But one of the things that's kind of triggered a bunch of this is data about vulnerabilities.
Okay.
And the data that's coming out, which is showing that a large proportion of vulnerabilities are stemming from this class of bugs, and these other languages, like if you take some of the dynamic languages, essentially these bugs still exist in the dynamic languages, except they aren't as easily made into like a vulnerability, right? And Rust has basically taken it and said, look, we are by construction making it so that you can't introduce these things. So you're actually not introducing the bug itself. It's not just getting rid of the blast radius. So yeah, a lot of new attention on this. Well, lots of questions and comments. I don't remember who was first, so I'm just going to sweep this way, if that's all right.
I think in terms of the facts changing, I think one of the big things is the existence of Rust, right? Before Rust, if you go to a program that says, is there any high performance memory safe language? And they say, well, we'd love to be memory safe, but we care about performance and efficiency, so we have to write in C and C++. Like Rust takes that excuse away from you.
I think that's a really good point. That was before Rust became considered a viable alternative, and that's changed. All right.
Is it less safe than Python 2.7? Because that's still roaming around. Your lift of getting C++ to Rust, I think, is probably a lot bigger.
Well, we'll go into all of this stuff. I actually do have more slides, which we'll get to.
You're going to need to cut off the discussion if you want to get to those slides.
I will at some point.
I apologize. Sorry. You asked for it.
Chandler, go ahead.
The other data that I think is new is we have a much more concrete economic impact understanding of vulnerabilities. There's been a lot better kind of systematic evaluation of the economic impact, particularly by governments of things like ransomware over the last 5 years. That's given them an economic model and a kind of like industry motivation model as a government to intervene that I think was lacking before. And some analogous things in the kind of defense and security sector have allowed governments to take a more active role than they did previously.
So I will just repeat for those who can't hear through the mics that Chandler was pointing out that there's an economic factor in this as well, and we have more data on that too. And we'll go to Lisa, and then I'm going to go to my next slide.
I don't want to downplay yes, there are real engineering problems, that this is stemming from, but reports like that mostly don't happen without lobbyists wanting them. And the lobbyists are not just launching them because they want software to be better software. Somebody sees a profit in this.
Lisa's comment is that maybe some of this lobbying is coming from someone seeing a profit motive as well. All right, so there will be more opportunities to. There will be more opportunities to chat. Okay. All right. I grew up in the 90s, and I saw a lot of commercials, way too many commercials. And this is one for Glad Ziploc bags. I guess I should call them Glad freezer bags, okay? And basically you have the spokesperson on the right who's saying, hey, we have this like game show here, and here is stereotypical housewife who says that her brand of plastic bag is better than Glad and she doesn't want to switch. And so what he does is he has behind him stereotypical wives, a stereotypical husband who is holding 2 bags of chili over her nice white couch. And his task is to change the pillows and fluff the pillows on the couch. And this makes stereotypical housewife extremely nervous, and she starts screaming, please use the Glad one, okay? And I believe that when it really comes down to it, for security critical applications, you'd much rather have someone, all other things being equal, you'd rather have someone program that thing in Rust, okay? It's just, it eliminates a major class of bugs by construction. So you might hear people say like, oh, you know, I trust C++ just as much as I trust Rust, but if it comes to like your like artificial heart or, you know, something extremely safety critical like in your car, yeah, there is something to this. It's not all hype. I mean, it actually is better technology for safety critical applications. All right, any comments on that before I move on?
So why am I hearing around the people I'm at, oh yeah, that's just a fad, this is what's gonna stay? Like, why am I not hearing more people saying, deciding to switch?
That's a great question. And maybe it is a fad. So, and that actually moves really well into my next slide. So hold your thought, we'll come back. All right, could be a fad. Could be just like, you know, nobody's really using Rust. It's just like everybody's claiming it's so great. Well, there was a Stack Overflow annual survey, okay? And it goes out to 90,000 people, which is, that's a good number of people, okay? That's a serious sample size. And what I did is I crunched these numbers and I looked at the number of people who program C++ and also program Rust. And I tracked this number over time. And in 2019, it was like 5%, and by 2023, it got up over 20%. So 1 out of every 5 C++ developers are also Rust developers. And the way the survey question was asked, it eliminated people saying like, oh yeah, I tried it, or something like that. It actually asked, did you use this professionally as part of your work over the past year? Something like that. Okay. Now, when I presented this before, some people say like, look, everybody knows the Stack Overflow is biased, right? Just a bunch of Rust fans jump in there and they just like add all these numbers, maybe making fake accounts to bloat this thing. Could be. Comments?
Has the C++, I don't know what community board would do this, have they also run a similar type of survey with these types of questions, and if not, why? Okay,
that is a great question. Turns out the answer is yes. The 2024 C++ Foundation survey, for the first time since the survey was opened, also asked the question whether or not you use Rust as another tool, which is actually kind of telling that they only did ask that question like last year, but they've asked like Python previous years. And the result was that 18.7% of polled C++ engineers said Rust is another tool they use. This is the CPP Foundation survey. So this is pretty consistent with what's going on in the Stack Overflow survey. Maybe all the Rust fans jumped into the C++ survey and did this too. I think probably not.
So we are here pretty randomized among all industries. Let's run the query here.
We're not running.
Okay. The comment was, let's run the poll here. Okay. It would be interesting. So with this very small self-selected sample size of C++ experts, raise your hand if you programmed Rust as part of your work last year. 1, 2, 3, 4, 5, 6. And then all the rest of you raise your hand. Okay, 6 out of, I don't know, a bunch, 30 something, 40?
Actually not that far off.
No, it's not really that far off for this, even this very self-selected audience of C++ experts.
So I guess my question here is like, if you were to ask like, do you also use Python? I would say yes, but not for the same kinds of things I would use C++ for.
That's right.
So is there any way to like, any accounting for that in these surveys?
I don't have that data, right?
So let's like rephrase the question to these 6 people. Raise your hands who programmed like real project which went live.
Whoa. I'm running the survey there. I'm running the survey. I'm happy with the results I got. But I have another thing I would like to point out. Right here, another kind of like indicator. So this is Reddit, okay? And what I did is I just went on Reddit, and I looked at the Rust subreddit, I looked at the C++ subreddit. And you'll notice that the Rust subreddit has 289,000 members. And the C++ subreddit has 279,000 members. So the Rust subreddit has more people in it than the C++ one, which is kind of interesting. I mean, it could be that Rust people use Reddit more than C++ people. Another thing that's kind of interesting about this is the number of people that are online. Because the number of Rust people that were online were 595, and the number of C++ people that were online was 162, which might indicate that a bunch of the members in the C++ Reddit community kind of just signed in and then maybe didn't participate after a while. What's that?
We're busy writing code.
Oh, they're busy writing code. That's right. Maybe the Rust people don't actually write code, they just talk about Rust. and they do surveys. What's that?
They're more productive, so they have free time.
Right. More productive, they have the free time. Okay, well, another number. For every 5 C++ PRs on GitHub, there's 1 Rust PR on GitHub.
20%. Sorry, how do you count this? Because like GitHub search is.
How do I count this? I count this by looking at the statistics tool, which does this for PRs. If you search Google, you'll find it and actually have graphs of the different PR frequencies of the different languages.
Do you duplicate and things like that?
I don't know. Look, if you don't think at this point that Rust is a real thing, like, I don't know what to say. Like, there's nothing I can say. All right, you had your hand up a while. I want to make sure.
Yeah, so it's not that I don't believe Rust is a real thing. It's just I don't really have a whole lot of experience with it. I mean, but earlier you had the slide where the holding the chili over the thing,
yep.
And you said, we want Rust. And my question basically is that, do we actually have enough real world experience with Rust running in these critical environments to actually know that they have much fewer defects, or are we extrapolating that from other models of where we see these bug stuff and just assuming that that's going to be the case?
Great question.
Those are really rigorous environments.
So there's a couple of things with that, and yes in some places and no in some other places. So where where groups have transitioned, I think there was like an Android study that came out recently, where groups have transitioned from C++ to Rust. They actually found a lower incidence of vulnerabilities, so that there is that data. For some of the security critical use cases, like I was chatting with folks at Toyota, they don't have approval for use in those situations yet, because like if you want to use C++ in a car, you have to go by MISRA guidelines, and there's like other like things that you need to do, these processes. And so these processes for some of these highly regulated industries haven't caught up yet to using Rust. So you have Rust, which is a great tool, but they don't have all this other stuff with it yet. That's still under development. So it really depends on like what you're doing in terms of like how proven it is in practice.
Can I just follow up? Just when we did the Rust things, I noticed you didn't raise your hand at all. What about you? Do you have experience with Rust?
What am I?
Principal engineer.
No.
C++ project?
You have a word for people like me. What is it?
A boffin.
I'm a boffin. I'm a boffin. I don't actually code stuff. No, I have programmed Rust. I have programmed C++. Yeah. I mean, do you count writing papers? All right. Anyway, question.
The point there about the sort of commercial with the Ziploc bags, freezer bags, and it's the sort of reaction maybe a lot of us have, like that sort of, okay, the lady's like, okay, that's my freezer bag, I know it could break. I don't know about this, and I guess it would be better, or why would they put on this commercial? Is there a lot of that might be going on, which is, I don't know about, I know a lot of the things that are problems here with this language, but I don't know of all the problems that could be there in Rust. So, gosh, maybe it's
Yeah. So this is actually, believe it or not a talk about Rust. And so I don't go into the details at all about why Rust actually is safer, especially in the memory safety area. You're just going to have to take my word for it and research it later. But I am telling you, like as someone who knows Rust, I'm not an expert, I know it well enough. I am fairly certain that on the memory safety front, it is a lot better than C++. It really, really is. Does anybody who knows Rust want to disagree with me? No. Okay. All right. I have one. Go ahead.
Yeah. So obviously, there wasn't these types of discussions when we've seen such charts for Python, right? Because we always knew that there are things that Python would probably do better than C++.
Yeah.
But Python wasn't gunning for everything. Like some stuff was carved out, and some remained.
It's not getting in our business.
Yeah. So, it's some of our business, but enough remains.
Yeah.
I'm trying. Is Rust gunning for our business? Is there anything that Rust claims to say this is not this C++?
We're going to talk about that. Yeah. I mean, but generally, the feeling is this. Right? You build your career as like a C++ expert, and then you hear all this stuff about legislation against C++. You hear about how Rust is like so much better, and you're like, wow, I mean, dang, what am I going to do? Right? And this meme, like, has anybody, raise your hand if you've seen this meme before? Okay, everybody knows what this meme is. I did some research on this meme. It's really ambiguous as to what it means, okay? Does it mean that the little dog there is like delusional and saying like everything is fine and just ignoring that the house is burning down?
Yes.
It could mean that. It could also mean that this dog is so cool and knows that like even though everything looks really bad, it's gonna be okay.
It's not that.
I don't know. But anyway, since this is, I hated putting this talk together. This is just so sad. Can we talk about C++ for a minute here? Oh shit. Okay, let's talk about C. Let's talk about C. So C is kind of like C++, but with a lot less stuff, right? More or less. It is actually quite popular, right? There is one CPR for every 2 C++ PRs. So C is beating Rust and like gets half as much usage, at least on GitHub, as C++. That's huge. That's huge. But why? Why is C being used so much if C++ is like C but more stuff? Well, I have some ideas. The first one is that libraries with C interfaces are very accessible, right? If you make a library with a C interface, you're gonna get like a Python binding and a binding in this language, a Lua, whatever, like in really short order, right? And so it's kind of become this Latin of programming languages. Like if you look at Latin as a language, I mean, you might think, oh, okay, Latin's a dead language. Okay, I don't want to get that association with C. I don't think C is dead. But when you talk about an animal or something like that, there's a Latin name for that. That's like the official name for that animal, that genus, that plant, or whatever. It's like this thing that's supposed to last forever. And C kind of has that quality to it. So when you have things like OpenGL or operating systems or POSIX or whatever, having that interface be in C actually buys you quite a bit, right? It's also really easy to learn and use. One of my kids is learning Python. He's a 10-year-old. He's like brilliant learning programming languages, and he's gonna finish learning Python pretty soon. And the next language I'm gonna put him on is C. Why C? Because the book's like this big, and you can program some really low-level stuff with it. It's nice. It's cute. It's good, and you get this low-level access without a lot of fuss. I can go and I can twiddle, this memory over here and do things over there. Especially fun if you're doing like circuits and Raspberry Pi and all that kind of stuff, which my son is doing. It's also very fast and stable. Right? Like I learned C, some multiple of decades ago, right? I haven't really gotten caught up with the latest C stuff. And I don't really feel like I'm missing anything either, right?
So how safe is C?
How safe is C?
Well, it's twice as safe as C++ because they write half as much code.
In terms of memory safety, I would say C is not great. Yeah. It's like C++, but worse. Substantially worse. Please don't write like a artificial heart firmware in C. There's got to be something better. Okay, I heard someone say, I got news for you.
Bad news.
Bad news. Okay, well, I don't have an artificial heart, so at least it's not affecting me today, but they're going to rewrite all that in Rust eventually, I'm sure, by the time I need one. Okay, other comments, questions before we move on? No? Okay. Yes?
Like a few years back, I heard a lecture called, I think, Up to Code. And I think one of the themes there was that, yes, there's the language, but then there's the process, and there's being an engineer. Why is the discussion focused on the language and not on the products and the engineering and the processes?
Why are we focusing on language as opposed to process, as opposed to that other talk, which, by the way, that was a really great talk. I gave that talk for folks that don't know. But I don't know, that's just not that talk. Like, this is a different one. Yes.
Yeah, just one thing that I think you missed there, at least in comparison to C++, C is really nice. And if I write a single line of C code, it's not going to generate like 50K of assembly code calling all kinds of things, because it turns out that the operator less than was overridden, and this thing is actually a class, and blah, 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 blah.
So the comment was that if you write C, you kind of get a sense of what the code is actually going to be generated, right? You get this much C code, you probably get, relatively speaking, this much assembly code. Whereas in C++, you might get expanded, although there's inline and then the macros, as people have mentioned. But yeah, it's all in there. It's simple. It's simple. Like, people like the simplicity.
In which one line of that language gives you exactly one line of assembly code.
We should all program that. Yes, that is a great language. For details.
One thing that's kind of relevant for C++, that thin little book, Kerning and Ritchie's, the second edition that you're probably going to, all of that code was written with C front. That's all C++ code.
Okay. Apparently the examples in the C book were, I've never written code with a compiler. How do you do that?
When they when they tested their code to see if it worked, and they ran the text of the code through the compiler to make sure they hadn't introduced bugs, the compiler that they were checking it with was the C++ compiler. They hadn't managed to write a C compiler that did declarations yet.
Thanks. I wasn't actually confused about that, but I appreciate the clarification. Okay, but I have a question. Why didn't C++ supplant C? How come we got all this like C stuff being written still, and shouldn't C just kind of should have faded away with C++? Why not?
Language of ABIs.
Language of ABIs, but you still do that with C++, right? You can do extern C.
It did. Well, it's the largest single code base in C versus the largest code bases in C++.
Okay. Other comments? Other thoughts?
Some people hate C++.
Some people hate C++.
Like Linus?
Yeah.
Comment in the back there.
What do we mean by supplant here? Because are we saying like, are we going by like C is number one still like on top of by some metric? Or are we talking about like active users and writers of C versus active users and writers of C++?
Okay, what does supplant mean? Let me just tell you that I looked up this word in a dictionary, and it was like spot on, but I don't remember the definition.
Replace.
Sorry.
I would say it's just complexity. Like, C++ is so complex. Like, not everybody enjoys that. It's not because it can't be better. It's just it's a lot more painful to do better.
Okay, the complexity. I'm not gonna sweep back over this way because I do have some more slides, but I will answer these ones. You can raise your hands. You put it back up.
There are thousands of times as many C compilers as there are C++ compilers.
There are 1,000 C compilers for every C++ compiler, which, man, that number sounds made up. But it could be right. It has that truthiness to it. Any more?
Yeah.
Yes.
So you can ask the same question about COBOL. Why do we still use? Some people still write in COBOL.
Yeah.
It's historical. Some more things are written in C already, and you need to support that, so you need to write C. Some things are written in COBOL. You still need to support COBOL or Fortran.
Yeah, some people still use COBOL. Some people still use Fortran. I wish I had run those numbers on GitHub to see if it compares. One last question over here.
Yeah, so it was kind of gotten to with the complexity argument before, but I think that one of the reasons why you mentioned Linus, I think one of the reasons I think he doesn't like it is that he argues that it's simultaneously too easy and too complicated, because it's really easy to write bad code that probably doesn't do what you want. Like if you come from Java, just drop all the references and copy everything. But at the same time, it'll blow your leg off when you get it wrong, and there's lots of really nasty ways that it will fail, and most developers will have very little ability to figure out what's going on.
Yep, good points. I am tired of talking about this. Can we talk about something else? Let me talk about my son, Peter. Peter's awesome. He's a blacksmith. I don't know how you get from parents that are, one's a computer science person, the other one's a math geek, and Peter is a blacksmith. But he is totally into it, and I dig it. Like, blacksmithing is cool. So he does blacksmithing work. There's his little shop. He took over one of my garages. That's fine. I'm not bitter. He did make me a very nice cooking knife, which is cool. But anyway, I want to show you an aspect of his shop. So this is Peter's collection of clamps. And he had to make a bunch of these clamps himself. And each of these clamps do a different thing. Like, some of them are for holding rods, and some of them are for holding different thicknesses of the flat stock, which you would use for making knives and stuff like that. And it's very cool. And here's a little snapshot of what's in his toolbox. You've got all kinds of different wrenches and things along these lines. And basically, he's got a lot of stuff. And whenever he gets a new wrench, you think he throws out his old wrench? No, because it's slightly different, right? You can use it for some kind of a function. So I have a question for you all. How many of you own an electric drill? Wow, a lot of people own electric drills. Okay, cool. Now, how many of you who own an electric drill also own a screwdriver? Okay, most people. Why would you own a screwdriver if you have an electric drill? Electric drill, you can put in the screwdriver bit in there, and you can do it faster. You can do it with without having to use as much energy.
Tight spaces.
Okay, tight spaces.
Finesse.
More control.
More control.
More destructive. No need for power.
Easier to grab.
Screwdrivers are
Cheaper.
Sometimes I forget to charge.
Well, cheaper, I mean, you already have the other thing. Any other thoughts?
Still need power, but it's your decision.
The audio quality is better.
What's that?
I forgot what we were talking about. Sorry.
Okay.
Not only do I have a screwdriver, I have multiple kinds of screwdrivers, not just, Phillips and flat blade. I have 6 different kinds of flat blade screwdrivers because they're a little bit different widths, the different dimensions, the size of the screwdriver. It's
So you can have an assortment of blades.
Some are magnetic.
Yep.
There are certain particular cases where that's just exactly the right thing I need, and the screwdriver electric drill would never work.
Yep, different types of screwdrivers.
David, I love this metaphor. I love where it's going. I agree with the theory. Are we going to get to the point in the slides where we talk about use cases where one would pick up C++ and the concrete use cases where one might pick up Rust?
Maybe.
Do we need to call security?
All right. So yeah, can we get our safety and inclusion first? Oh, shit. All right. Look, basically, can this be our toolbox? Can we have some Python and some Rust and some C and some C++ in our toolbox? People want to comment about this. I mean, I think it's an easy answer, but whatever.
I think that doesn't really work out that way because of scale, right? We have, if you look at the languages, every language dominates in its niche, right? Python, there was Perl, there was Snowball. Anybody ever programmed in Snowball now?
Yes.
It was supposedly the language for doing string stuff, right? Well, and then there was the AI language was Prolog, right? This was the AI language. Python, because it was good enough at every single niche, pushed out all the languages pretty much except the ones where it ran into hard performance issues, right? The thing with C++ and Rust is they are in the same niche. They are the ones where
I'm going to stop you because it's my talk. But we're going to talk about that. But I'm not going to answer these questions right now. Okay, maybe Bob.
One really quick question, David.
Is there a subliminal message in this slide in the relative sizes of the languages?
Okay, good question. No. I put these things in there and I was like, oh crap, Rust is too big. And then I was like, oh, am I gonna go through and resize all these other ones? And I didn't. So there's no subliminal message here. All right, but basically, I wanna get to more slides. Like, I didn't get a double session for this, I probably should have. But the question is, like, do we need C++ in our toolbox if we also have Rust? Like, Rust is supposed to be the greatest thing since sliced bread. We already know that it's more safe. Why would you need C++? All right, I'm gonna give you my answer. My answer is yes. Yes, I think we need C++ in our toolbox. Maybe not everybody's toolbox, like my toolbox, yeah. Why? Why? Well, there's all that existing C++ code, right? Can't really do much with it with Rust, you know, you're gonna have to deal with it. There's all that existing unsafe C code. We talked about how unsafe C is. Like, if you want to take in like a bunch of C code and make a Rust library out of it, it's not like a straightforward thing, because Rust has completely different idioms and things like that. Unless it happens to be like a safe, so like it maps very well into a safe Rust thing. And the third thing is that Rust design has a bad trade-off set for some problems. It really does. This was an article that came out just last week about Rust game dev. So this was a team that had been working on writing games in Rust, professional games, they want to sell them, for 3 years. And at the end of this 3-year experiment, they said, we're not gonna do this anymore. This is problematic for us. And then it switched to C++. I think it switched to C#, but it doesn't really matter what they switched to. It's the fact that it didn't work, okay? Why didn't it work? And this article is fantastic. If you're interested in learning about it, like, I very much recommend. It's long, but it's very good. It basically boils down to a few things. Well, I didn't really read the whole thing, but like, these are like 3 of the really big things, okay? The first one is that it's a higher upfront design cost. When you're developing something with the constraints of having the language requiring it to be able to prove everything that you write is memory safe, there's additional constraints and it's hard. You have to do some upfront design cost. You can't just like go and like twiddle this bit over there. You have to think really through this thing. And they found that the idea exploration was not rapid. It was hard for them to say like, oh, well, let's try this other thing. Oh, well, we have to do a big refactor because of the safety constraints. Whereas in other languages, you could just like, oh, let me quick try this, this thing. And it also kind of leads you to do things that are overly abstract, less concrete. And so they found out that it basically didn't really work for them.
Did they have previous experience with Rust before they did this?
Yeah.
They had 3 years of experience with Rust, like trying to use it professionally. So maybe at the beginning they had some ramp up, but I mean, they got pretty good at it by the end. Certainly by the quality of the article and they knew what they were talking about. So yeah, Rust isn't really for everything. Maybe it could be for the majority of stuff that we do that we probably should be using Rust, but it certainly isn't going to be for everything. That's not what's coming out. And so I'm arguing, and what I see is that C++ is uniquely fit right now for several domains. Abstracting low-level C stuff, it's great. You get a low-level C library and you want to put some abstractions on it and use it. Nothing is really beating C++ in this space right now. Embedded, real-time, this is like where you want to do this kind of abstraction on low-level stuff. It's great. Scientific computing, where you have people that aren't like language experts, that are just more like scientists and they need to like get stuff done. This C++ can be a very useful thing. Performance critical, rapid prototyping. Like if you're making a game and you're like, okay, I just want the pixel to move around here. Like how do I access the frame buffer and do something fast? Like C++ is great for that stuff. What other things do you think C++ is like uniquely useful for?
It's great for binding to Python as well. It's better than
Great for binding to
Python has its problem that it's slow. If you create something binding in C++, you get a speed bonus.
Yep.
Rose can do that for you.
Other comments?
For similar reasons as scientific computing, quant finance, you've got the non-expert programmers who need to produce high-performance code. and they can reuse the tools.
And quickly, and like they quickly iterate.
And
Yeah.
iterate and throw out last week's model and come up with a new one.
Yeah.
Does anybody know anybody in the HFT space playing with Rust or doing Rust in production?
In a company called Final, they are doing this.
Oh, great thing.
Yes. Other comments, thoughts about this question?
I think just scientific computing in general should be just generalized to HPC, because scientific computing people think of like, like math formulas, matrix. There are basically any kind of algorithms that shuffle huge quantities of numbers around. They're not traditionally called scientific computing, but it's just the narrowness of that definition broadening into high-performance computing.
Okay. Yep. I'm going to take one more comment back there.
So, from my experience, also interfacing with graphics API like Vulkan, because not all the Rust wrappers for it are good enough, and also everything is unsafe, so you just make everything unsafe because you have calls everywhere, and then you don't get much of the safety.
Yep. So like there are a bunch of use cases for C++ that are completely valid and useful. There are also some use cases for Rust that are completely valid and useful. Like if you're reading untrusted data into your program, like a JPEG or something like that, I would recommend Rust over C++ for that kind of a problem. But for a bunch of other problems, like C++ is good.
I think that statement needs to be clarified. If you're reading, it depends on the environment. If I'm in an environment where basically the person giving me the data, which can be untrusted, is basically like VI, I can probably trick VI into erasing my entire disk. I can erase my entire disk without VI. If that's the whole environment, the security of that editor is irrelevant.
Yes, there are more aspects of this. Sorry, I'm not going to take your questions. I do actually have more slides. And the next one is a key observation here. If a new tool comes out for like Peter or for us, it doesn't make the old tool less capable. It doesn't. The old tool does the same stuff that it could do before. New tool doesn't threaten the capabilities of the old tool, right? It really doesn't. So, but there is something that actually can make C++ less capable of a tool. I'll give you a hint.
The government.
No, Standards Committee. Standards Committee, for real. So how is the Standards Committee a danger to C++'s utility? One word. Saying yes. Anytime they say yes, and the standard changes, there's a risk to C++'s utility. There is. It's the only organization in the planet that can go into your toolbox and screw around with your tool and make it different. And the C++ committee, as you can see, is started about this size. This was the original group. And as we move forward in time, you can see that it's increasing in size, and this was C++ 20. You see how many people are on the committee there. Now, most people in here probably have worked for a company and have seen what happens when you take a project and you say, hey, that's great, we love what they're doing, let's add 200 people to that project.
Preach.
What happens? I'll tell you what, let's add to that the fact that there are no real project managers, that everybody going into this project can decide what they want to do. What's going to happen? Yeah, it's, I can tell you, we haven't been dealing with this very well. We really haven't. And I'll prove it to you later. Why do people join the committee? Okay, comment back there.
So you said a few minutes ago that you haven't paid a lot of attention to what's been going on with C since C89 or whatever, and you don't feel like you're missing much. Isn't the worst case for C++ something like that? In other words, the committee doesn't really sabotage C++, it just stops being relevant?
Relevance is a different question, but would it be fine for C++ to like not change anymore? I would be happy with that, like given what the changes that I see happening right now. I actually would. So
I'm asking if is that change actually worse than no change, since we have the ability to opt into no change?
I don't know that we have the ability to opt into no change.
Okay. What do you mean by that?
Well, I don't want to go too deep into that because, believe it or not, I actually have some more slides. Like I will have a time at the end, and we can discuss this all week, right? But I do want to like get through some more things. Why do people join the committee? Why do we have like these 3 million people? Sometimes it's to represent corporate interests. Sometimes you'll have a corporation that comes in there and says, hey, I would like to get this particular feature because it'll make more people buy my widget. I've seen it happen. It doesn't happen that often. It does happen though. Some people come in because they want to change C++'s direction. They're like, you've all got it wrong. We need to go somewhere else. Some people are in it because they want to be stewards of the language. They like legitimately care about having C++ be of utility to mankind and try to improve it. You have some people that want to integrate particular features. There's a lot of those. Like where someone comes in, it's like, oh, I got a pet peeve and I want to get this sucker in the language, right? I see a lot of that. And some of it is just notoriety and recognition. Like, hey, you go to a local meetup and you're like, hey, did I tell you I'm on the Standardization Committee? Yeah, it's pretty cool. It's pretty cool. No, not that big of a deal. No, seriously, it's a thing. Like, it's real. It's real. But really, one of these kind of holds the rest of them in check. And that's the whole stewardship of the language thing. If you have the stewards of the language kind of holding the reins and like really trying to focus things, it can work. But it cannot work if that doesn't happen. And so what happens when stewardship gets overshadowed by all these other things, right? 3 things I identified. One is incoherence. You have stuff over here, which contradicts stuff over here, and then all of a sudden, it doesn't have like this coherent story behind it. It's just like a bunch of different things moving in different directions, right? Same thing when you throw 100 people on a project. You get complication, where it's just super duper complicated, and scattered direction. Like, what is C++ doing these days? Well, you could make a list of like 500 things of what C++ is doing these days. So I have some case studies. First one is studsimd. Okay, so in Fundamentals of Generic Programming, okay, this was a document published way back in 1998 by Stepanoff and Dinhart. Sorry, I probably am butchering that name. But they came up with this idea of when you make a type in C++, if it's representing a value, you use double equals returning bool to say whether or not this object has the same value as this other object. And the assignment, A assign equal to B, right? It means that A is going to have the same value as B after that assignment happens. It's just some really, really basic rules that tell you about like what can change and what can change other things. And regularity is what this is called, and it buys us a lot. Okay, you can have algorithms like studfind. If you have a regular type, you can use studfind with it without having to spell out what function is going to be comparing the things. You get language features like operator double equals default. The only way that works is if you are consistent about what you have the double equals operator do. And this also lowers teaching costs. When you're using JavaScript and you need to figure out how to tell if 2 JavaScript objects are equal, have the same value. It's a complicated story. It's like if it's an int, you use double equals. If it's a string, you do like dot equals or something like that. It's very, very complicated. But in C++, it's not. If you have a value type, you just use the same thing everywhere. It's simple to learn. You apply it everywhere. So the SIMD proposal has double equals returning something other than bool. You have 2 SIMD objects. that could represent the same value. Double equals won't return true. Returns a mask, right? Like individual elements, does something different. And if you look at it in isolation, if you've just got your SIMD goggles on, you might see, okay, that kind of makes sense. It's consistent with plus, because plus is lane-wise. Other SIMD libraries out there do it this way. It's even been said, like, maybe this is a different value semantic category, like a different regular. It's a SIMD regular, right? Like just building out this complex thing. When you try to put it all together and to try to make a coherent whole, a coherent standard library, a coherent language, it doesn't work, right? And it's not the SIMD thing that bothers me. It's that individual decision made over and over and over again of making things incoherent. And so we tried, right? Wrote a paper with Joe Jevnik to say, like, look, SIMD type should be regular. Gave a presentation on it in the committee. And that didn't work, so we got Jeff Garland involved. Jeff Garland came in, we made a presentation, and didn't get in, didn't win out. Right now, SIMD is going to be a regular. It's going to be contradicting regular. In the attempts to address this, we were consistently met with calls to avoid discussion. Like, no, we already discussed this way back when SIMD was a TS. Like, why are we rehashing this discussion? We never even had a direction poll which compared to see what had more consensus, this route or this route. And this is what happened. Like, I don't have a plan to fix this. This is what's going to happen. So there's another troubling trend, and this is expert-friendly stuff. Okay, so in Direction for ISO C++, the direction group came up with this comment. They said the average programmer is seriously underrepresented on the committee. What you get instead are like people that are C++ experts, like the people that can do the complex template metaprogramming that sometimes can't see like what a basic programmer is going to react to a particular library interface. So a case study for that is thread attributes. Okay, so the basic idea behind this proposal was, hey, when you launch a thread, sometimes it's nice to be able to set the thread's OS level name, right? And sometimes it's nice to be able to set the thread's stack size, right? Solid features, solid features. I don't think anybody could disagree with the idea of having thread attributes being passed to when you're launching threads. However, you look into the wording details of the paper, and I apologize, you're not going to be able to read this, but essentially thread used to take in a function parameter, the function thing that you want to run in the thread, and then a bunch of arguments, right? And now it changed into thread just takes in arguments. And what it does is it goes through the arguments looking for particular types. And when it finds the first type that isn't of these particular types, now it knows that that one is the function parameter, and then the ones after that are the arguments. And it's just a complex thing here. And it says like ATTRs can be used to tailor the thread with additional implementation-defined behavior. So you add these special attribute parameters at the beginning. And ultimately, you get this kind of an interface, which hopefully you can read, where you have named parameters, right? The first named parameter is thread name hint. The second named parameter is thread stack size hint. Really clever, super duper clever, but super duper complex and not like C++y, right? We're getting into complex template metaprogramming magic, and people aren't going to understand this. Like, what if you try to instantiate one of those things without that and then try to put it in there? Like, is movable? Like, all these questions come up. So myself and Darius Nietu wrote a paper called A Boring Thread Attributes Interface. Let's do it really, really simple. And you can see the comparison on the bottom here of what we do. We say, hey, you create an object of type attributes. You set the name, you set the stack size, and then you pass that attributes as the first parameter when you launch the thread.
And you return a reference to this, so you can chain them.
I didn't even do the chain thing. Like that's too complicated for me. I'm a simple C++ programmer. And this didn't get consensus. The folks on the committee, they wanted the more complex thing. So another...
Do you actually have the more complex thing in the standard?
Yeah, it's on its way. It's not in the working draft yet. It's past design review. So Jihao Yan said, okay, this is bad stuff. How about another simple way of doing it? What if we, just pass the structure, and then you kind of get your named arguments if you want that, but if you also want to name your attributes thing separately, you can do that. Right? This is just using the normal C initializer thing. I forget what it's called.
Designated initializers.
Designated initializers, thank you. And no, that was rejected too.
To me, the weird thing here is like, why is it that thread has to start even, or do you have to know what is starting right in the beginning? Like, why not just have the construction be very simple and then set things on the thread?
You
can set a name sometimes.
Yeah, but who cares?
Okay, so
who cares about names? Stack size is what matters.
So I don't want to go into the details of this proposal because we could dive like really deep in, but there are good reasons as to why you can't set it after you launch the thread, because it's too late.
Just like at a high level, what were the main arguments against both of these proposals?
So the main arguments against the proposal, I think the first one is that this is the way the authors wanted it. The second one is that they were worried about the potential that someday we might add another attribute. And if we use the same data structure, that could be an ABI break. But both of these actually would be fine with an ABI break, or fine with an additional attribute because you just use a different data structure and you have another overload. Like we could make that work. So that wasn't a very strong argument. I'm going to move on because I have more examples, okay? And we can debate this later. Another case study is sender-receiver. Okay, and I really wish you could see this code, but you might not be able to. This is an example from the sender-receiver repository of creating what's called a retry sender. So this is a sender that will take another sender and just retry it over and over and over again until that sender produces a value as opposed to an error. And this example gives you an idea of what senders actually look like under the hood. So you'll see 3 hidden friends overloading this thing called tag invoke. Okay? What's that?
Which is gone, by the way.
Zzz. I'll get to that. Wait,
Spoilers.
Punchline spoiler. Okay. So you have tag invoke, and the first argument to tag invoke is this this thing called get completion signatures T, which is like a special tag that tells you that this is the special invoke function that gives you the completion signatures of the sender, which is essentially like, what's the sender's type? What does it produce, like an int or whatever? What kind of error does it produce? Another one, a tag invoke overload here, takes a connect tag, which connects the sender to a receiver. The other overload has a getEnv tag, which gives you attributes of a sender. I'm still not entirely clear on what is an environment, what kind of attributes would you want in the sender, but whatever. This is complicated stuff, right? It really is. And if we unleash this onto our users, they're not going to have the same reaction that experts are going to have. Experts might look at this and be like, hey, that's a really clever way to deal with ADL or whatever. Users are going to be like, whoa. Okay. So Ville Voutilainen came up with this paper and he said, look, let's simplify the way that we do these member customization points. And this is what it looks like with what Ville suggested. You see, it's like a normal function called get completion signatures, and it returns the completion signatures. A simple function that called connect, which connects it to a receiver. A simple function called getEnv, which returns the environment. Good news is that this one was accepted, right? But this was after we had already approved the previous complicated design. Right? You're seeing a trend here. Things get approved that are really complicated, and then other people have to do the work to say, please don't do this complication. And it's much harder to change something after it already gets approved, I can tell you. Another example, stood optional versus stood maybe view. So there was a proposal, and we have author over here, that was introducing maybe view, which is another stood optional type that is different in sometimes strange ways. So both of them you can construct with empty arguments, you can construct with a value, you can assign to a value, but only stood optional would have dot reset or dot in place. Both of them would have some of these monadic operations like dot transform, dot and then, dot or else, but only optional would have dot has value, the Boolean check, the dot value or. Why? Why do we need a second type? The main reason was because we wanted to be able to have like a range, like be able to treat an optional as a range. But the answer was this, and this is the design that got approved in LEWG. And fortunately, we were able to write a paper and not include the stood maybe view. We were able to reverse that decision and have that. So I have like some good, there has been some winning here. But for me, I've basically stopped writing papers. I only write anti-papers. Like I used to be all involved in like writing features, but what I'm seeing is this complexity and incoherence being such a detriment to what's happening in C++. I feel like full time I should only be writing these anti-papers. And that's that's the state of the world. It's not great, which is another reason why I hated writing this talk. Then we've got some of this kind of stuff, right? Herb Sutter with his CPP2 trying to say that C++ should maybe eventually look like this, where you've got, I don't know, doesn't look like C++ to me, right? And maybe it's better. Maybe you prefer this. Maybe you think, hey, there's a lot of this is a cool language, right? This is neat. But every time we add more stuff to C++, another layer of complexity, you're not actually making the language simpler. You're making it more complex. Like, do you think about like the companies that you work for? And let's say this gets integrated into the standard. Do you think that people are joining your company are going to be excited about programming in this style? Because they're not. They're going to be programming in whatever like your gigantic code base already has in it. You can't just know the new stuff. You got to know the old stuff. Right? I would not accept a C++ developer and say like, hey, they are fully trained if they don't know what new and delete do. Because it'll come up eventually, right? You can't just know unique pointer. I want you to know unique pointer, but you can't just know it. You need to know some of this other stuff too. So building layer upon layer of complexity is what is making C++ an old crufty language. It's the newer thing which makes the old code look different. That hasn't happened to C. Right? You don't think of like the old crufty C, I want to use the modern C, right? No, it's all C, and it's fine. It doesn't have that bad reputation. So, what I'm seeing is with C++ incoherence, complexity, and lack of direction, this has been increasing over time. It's corresponding with the amount of people joining the Standardization Committee, and it's increasing training costs, which is a really big deal, right? When someone comes in and they need to know C++, they need to know a whole lot more. And not only is that training increasing because of what they have to know, but it's because of the reputation C++ has as being complex. People don't want to learn C++. When I was in high school, C++ was the thing. I learned C++ and everybody's like, wow, you learned C++. That is rad, man. But that's not happening anymore, right? It really isn't. Talked with some people. I have. And ultimately, this increased our maintenance costs. We have a bunch of C++ code. We need to hire C++ developers to maintain it. The C++ developers developers in general don't want to learn C++, which means they need to be compensated higher in order to be able to fill the positions, if you can even find them. So, we shouldn't be worrying about C++'s longevity. C++ lasting forever, it's going to be the greatest language all the time. The thing we should be worrying about is the longevity of our C++ code, right? The value that people get out of our C++ code can change if C++ becomes more complex over time. You know, our code produces some value, right? And then there are some drawbacks to maintaining it. You increase the drawbacks of maintaining it, and now the overall value is less, even though the benefits are the same, the cost is higher. And I think that we should be paying attention to this. So please do write simple idiomatic C++ code, right? Use simple libraries. Don't grab the complex thing. Use other tools when warranted. Use Rust when it makes sense. It's fine. It's like you're not like committing some crazy heresy. And advocate for less churn in the committee. Please don't make this language more complex. Don't veer from core principles like generic programming, and please don't try to make C++ into other languages. Those other languages are fine. We don't have to try to like be everything to everybody. So I want to give a message of hope. I would love to say, but everything's back normal and like now things are going better. I can't say that. We have some battles that have been won, we have some battles that have been lost, but overall the trend is continuing. Don't really know what to do with that. So I'm not leaving you with the message of hope, I'm just telling you I wish I could. I don't have it. But there is actually something that I'm very excited about, which is the Beeman project, which hopefully all of you went to the early morning session this morning. This week, happening at CppNow, we are organizing a new project called the Beeman Project, and the goal is to improve the quality of standard library proposals through community engagement. Being able to try a standard library proposal and have a website which has documentation and a not weird build system that you can use and integrate with your stuff. And by the way, everybody's invited. It's a community effort. This is the library in a week is working on this project this week, and I'm very excited about it. So that's a high note, I guess. So that concludes the talk. C++ should be C++. Hopefully you know what that means now. Now we can get into the really heavy stuff. All right, starting over. Bob.
Yeah, David, so, not to put you on the spot, but when you talk about complexity, you gave a lot of examples of complexity in library design. If memory serves, you didn't give any about the language itself. Are you conflating the two by claiming complexity and said it's all getting complex, but really you were talking about complexity in standard library. What are your thoughts on the language itself?
You only need coroutines to see the language itself.
It's a good question. The reason why all of my examples are libraries because that's primarily where I've been participating these days. I think the same thing is happening in the language, but I'm not as involved in it. But coroutines are very complex.
And one follow-up. So is the genesis of the Beeman project part of the frustration that you described to us here today?
I think it's part of a shared frustration.
Well, yeah.
I didn't. This has been a project. This is Jeff's genesis of like his project. So I can't claim credit for it, but certainly my enthusiasm for it is definitely part of my own interest in it.
It's interesting you mentioned about how a new C++ could be, like when someone comes in, they're like, well, I've got all this old code. But I would say C++ 11 is a new code base. Like looking at it, you went back in time to old revisions, you look at the code, it can look very different now. And in fact, it's sometimes hard when you see code that's in the mixture of the two. You're like, oh, what's going on here? Can I modernize this? But I think it's moved, and it shows it can move.
Yeah, so C++ 11 shows that it can move, and I see C++ 11 as a big improvement, and then 14, and then 17, and then I don't know what happened. I thought 17 was actually a really great release.
Yeah.
All right.
So I don't mean to put you on the spot, but I kind of do. Also, great talk, by the way, David, as always. So what % of the committee do you think is stewardship, like members of the committee that are stewards of the language? Question 1. 2, how do you advocate for less churn on the committee? Like, how do we advocate for less churn on the committee? And 3, how do you balance being what is the barrier to entry in the committee, and how do you balance being inclusive and also just restricting a working group to the number of people where it's actually prone to productivity?
Okay.
You don't have to answer all of them. We can talk about it later.
Okay, well, I'll answer the first one. I was able to memorize that one. And that was how many people are actually, what percentage of people are stewards?
Yeah.
And I wouldn't answer that with a percentage. I would answer that with how many people. And it's what you could hold on 2 hands. There's not a lot. And I think there are people that have goodwill that want to be stewards, but maybe don't have the experience yet on it. But for people are doing that, there's not a lot.
Okay, answer the second
And
one.
folks have left. We've had good stewards that have left the committee for various reasons. Titus Winters left. Google. That's your fault. No, actually, Titus is working for us now, so that's on me. But yeah, and for various reasons. And I think some of it has been seeing some of this happening and just we should put resources on finding ways to get off of C++. And that has definitely happened as well.
But how do we advocate? And then that's the other question.
The only other question? Okay. How do you advocate? If you are working for a company that's on a standardization body, you can say, hey, representatives, maybe stop showing up. Or if you do show up, this is something that's very important for us. And it's not about your personal interest in the committee. It's about something that's important for the community at large that is not being addressed. And then getting on the committee, I won't answer that question because a lot of other people have questions, but yeah. All right, other questions? Back there.
So if the US government, for example, were to pass a law saying that software companies could not sell commercial licenses with limited or no liability, do you think companies like Adobe would very quickly drop C++ from their products? Or do you think they'd just accept that as the new cost of doing business?
That's a good question. Well, it doesn't happen like that, right? It doesn't happen one day, boom, this happens, and now Adobe's oh shit, we write everything in Rust, right? No, this is the beginning of a long process. These things are shots over the bow or whatever the thing is. They're letting us know this is coming. So what Adobe is doing right now is we're how are we going to address this threat? How are we going to make sure that we are prepared for when this comes down at the various different stages? So yeah, we're investing in Rust. You bet your butt we are. Yeah, we're looking at, what are we going to do about C++? But C++ was always a problem for us just because the deciding factor is our developers, right? If we want to spin up a new project and get 10 people on it, from the outside and hire them, that's going to drive our decision to not use C++. It's because we're not going to be able to get them in time to be able to implement the product, right? So we're going to go with another language which actually has developers that want to program in it or want to learn it. Anyway, hopefully that helps answer your question.
Hire some committee members so they won't show up to the committee.
Good one.
Yeah, so you said that about complexity, that even if you know how to use shadow pointer or smart pointer, you still need to know new and delete. And I think there is a difference between features and things that should be used for high performance library implementation, and then there is for higher level usage of this library. I'm wondering what are your opinions about epochs or profiles, something that can compile time validation, separate between usage and restrict it?
So question about epochs and being able to separate out, this might be the fancy new C++ and you can only do that in this module and the old stuff is something else. That might help mitigate some of this, but ultimately, if someone joins the Photoshop team, we can't have them just use Herb C++. They need to use the real C++ that's in our code because we've got 30 years of accumulated code. It's not useful for someone to just be able to use the newer stuff. It's just, we're not going to have enough work for them to do, basically. All right, so I'll hand over here.
Yeah, I just want to make one thing clear. I voted for Dave's proposal over mine.
He did.
And it's like, but one of the reasons we were able to get that across the line is because of churn in the committee. Entire turnover of library evolution since optional was put in place, and there was consensus initial 15 years ago, before we were involved. Optional is not a container. It should not have begin end members. This is horrific. Because there are people now on the committee and not the people who made those choices then, we can revisit some of these things and say, you know, let's just do that. We can make optional range link and it's fine. We figured out optional references, which we might, if I don't mess things up, we might get for St. Louis and for C++26. But there was a lot of consensus building with a lot of people, like, you're making the wrong choice. The way that optional tref has to work is not the way not the way references work in the language. Therefore, we should not do this, despite the utility of this. And the existence proves that Boost Optional has had this for nearly 20 years now. There's a lot of trade-off with getting new blood into the committee versus old guard. And for a lot of things, there's no change until the old guard has retired. So there's some balance. I don't know how to strike this up.
Sure, I'm not really sure how to respond to that. I wasn't there when they made that decision. Of course, I'd like to think that if they had heard my eloquent arguments back then, it would have been different, but who knows, right? My concern isn't really the churn in the committee as much as it is the massive growth of the committee. Bryce LeBach once mentioned to me, he was like, you know, if we had a committee with just 8 people on it, I don't care what the 8 people are, just 8. Like, picked at random, that could be a lot better than what we have right now. And I think there's some truth to that.
The other thing that is seen is that the general competitors are implementations, not standards. And it's a lot easier to make progress on an implementation than a standard. Rust can move a lot faster. They just roll out a new version. And it's like, and if for some reason it doesn't work, they can say, that was a mistake. We're fixing it next time.
Well, the only thing I'll say on that, and I want to get to other people, is that we were able to standardize modules a lot faster than we were able to implement it, so I don't know about that. All right, but okay, we've got a question over here.
So a couple of years ago at a CppCon standard committee talk, I asked a question about resources for the committee and for the C++ community in general, about like definitive directions for C++ and proposals and like what's on the table, off the table. And the response I got was that the wealth of proposals that are coming in, sometimes conflicting, sometimes in different directions, that's the committee functioning as designed and intended. I would like to revisit that question about what do you think about having that sort of like resource or decision for the committee to follow particular directions, or allowing for the committee to continue to allow for a variety of viewpoints and proposals like it is right now?
I will say that the ISO process was developed for a small group of people to be working on a project that's relatively short term, actually. And it's not designed for what we have right now. So we have Herb that's like doing his best to try to like manage this by making subgroups and like these leaders over here and all this kind of stuff. but ultimately, because of some ISO rules, like you really have no command and control. There's no single decision maker. You have the direction group, which was an attempt to try to say like, hey, here's the direction we should all go in. And the committee just kind of like, oh, look at the direction group came out with a paper. Is there anything in there really? I mean, like, and just keep pushing their own paper, right? It hasn't worked. And I wish I could say I know a great solution for this. Don't.
You could have a non-committee language governance body. A bunch of languages seem to be succeeding with non-committee structures.
Are you aware of anything that would be like in this space?
And then Oracle buys them.
How well would such a governance model work in in that future world we're seeing of like government regulation of software development and languages being used? Does that fit in that future?
Well, I think that there are two paths to having a different governance thing. One path would be, we're just going to fork the language or write a brand new language that's even better, maybe even call it Carbon, I don't know. But that's actually doable. Like I could see that potentially happening. But given existing ISO constraints, there's no way, I'm not aware of any means to get something out of ISO once it's in ISO. Like there may be some path, but I've never heard of it before. It would be quite extraordinary. Okay, any other last thoughts before we close up? Okay, 2 popped up. All right, we're gonna take these 2 and then we're gonna end it.
Do you think C++ will ever be done?
Do I think C++ will ever be done? Well, as soon as I hear of a language that has been done, then maybe we can talk about that. But as long as we still got COBOL and Fortran out there, like...
There is new standards.
Well, they have new standards. It's really the code. Like, I do not see...
By done, he means no more changes.
No. Yeah. Oh, no more changes. Yeah. Oh, yeah. Yeah, that'll happen eventually. I mean, I would... If they're still standardizing new revisions of C++ in like 10,000 years, I just can't see that happening, really.
We still wouldn't have reflection.
All right, I had one more hand over here.
So is the Linux model a good model?
Is the Linux model, I guess you mean the governance model?
Yeah.
Where you have like a supreme dictator?
For decades, right? It's still working.
I think it seems to work over time until the benevolent dictator dies, and then we don't, or retires or whatever, and we don't really know what happens after that. Like Guido with Python has been doing an amazing job, right? Except for the Python 2 to Python 3, that was worst of it. But after that, he seems to be doing pretty well. Like Python has a good reputation, like it's still quite popular.
Down this dictator for life like 4 or 5 years ago.
Oh, okay. Well, he stepped down. I want to wait for him to actually die, though, and then give it another 30 years to decide if that worked, right? But we'll see. We're still new in this. Maybe we can learn from other fields. I haven't looked into it. Okay, that's it. Thank you all.